We will now check if each of the seven statements are true or false. So let's consider the first statement. We are given that differential functions are always continuous. So we see that this is true because by the definition of differential functions, they are always continuous. That is, only continuous functions are differentiable, and this means all differentiable functions are continuous. Now let's check the second statement. If f of x and g of x are increasing on an interval I, then the product f of x times g of x is also increasing on I. This is not true. We say that this is false. Let's understand this diagrammatically. Let's suppose that I have the function f of x defined in the interval, and this is increasing like this. In the interval, this is a comma b. This is f of x. And on the same graph, I'm going to put g of x, which is also increasing. But let's consider like this. Let's say it is increasing like this under the same interval a comma b. Let's put some values here. So here, let's say this is 1, and let's say this is 2, and this is 3. And here we will put, let's say this is negative 3, and this is negative 2, and this is negative 1. So as you can see clearly, this function f of x is increasing in the interval a comma b, as well as this is the function g of x, and this is also increasing in the same interval a comma b. So when we find the products, that is, let's find the product at each point. So at this point, the f of x is 1 and g of x is negative 3. So 1 times negative 3 is negative 3. We get negative 3. And at this point, f of x is 2 and g of x is negative 2. So 2 times negative 2 is negative 4. And at this point, this is 3, and g of x is negative 1. So it is 3 times negative 1 is negative 1. So as we can observe that if you observe the product of f of x and g of x, this is f of x times g of x. We see that from negative 3 to negative 4 it is decreasing, and after which it is increasing. So there is no guarantee that though the functions f of x and g of x are increasing on the same interval, it's not always increasing. And so we see that the statement is false. Now let's consider the third statement. Here we have a continuous function on a closed interval always attains a maximum and a minimum value. And this is true because according to the extreme value theorem, it is true that a continuous function should always attain a maximum and a minimum value. Now let's check the fourth statement. That is, if f prime of c equals 0, then c is either a local maximum or a local minimum. It is not true. So we say that this is false because if f prime of c equals 0, then only f of c is either a local maximum or a local minimum and not c. So therefore this statement is false. Now let's look at the fifth statement. Continuous functions are always differentiable, and this is also not true. That is, this is false, due to the reason that if I have a continuous functions which have a cusp as like this, or if we have a continuous functions which have vertical tangents like this, then the function is not differentiable where you have the curves as well as where we have the vertical tangents. So due to this reason, the continuous functions are not always differentiable. Now let's consider the sixth statement. Here we have if a function has a local maximum at a c, then f prime of c exists and is equal to 0. This is true according to the definition of the local maximum, or if we have to find a local maximum, then we have to find f prime of c and set this up equal to 0. So at local maximum, f prime of c equals and should be 0. So this is true. Now let's consider the last statement. We have f of x plus g of x and we find its derivative, and this equals f prime of x plus g prime of x. This is true by the algebra of the derivative of two functions. That is, if we find the derivative of sum of two functions, and this equals sum of the derivative of each functions. So this is true.